Hello everyone. Today I am here with you all with the third chapter of class 9th maths, that is coordinate geometry. So before starting with the topic, let's understand what coordinate geometry is. Coordinate geometry is a branch of mathematics in which we study the combination of geometry and your algebra. That simply means it is a branch of mathematics in which we study geometric shapes algebraically using coordinate system like your Cartesian plane. So already we have learned in our previous classes that how we can locate the points or the numbers on the number line. Suppose I am saying that this is a number line. What we are doing in the number line, in the center we are taking 0. In the right hand side we are taking the positive numbers. In the left hand side we are taking the negative numbers. Now if we have to locate the natural numbers or the whole numbers or the integers or the rational numbers, we know how to represent it on the number line. Now, instead of these numbers, suppose there is a plane is given to us and we have to locate any object in the plane. Suppose this is a plane, and in this plane we have to locate this point, this object is there, and we have to locate this object with one reference. So is it possible to locate this point exactly precisely using one reference only? So just let's see. Suppose I'm going to say that this point is 3 centimeter from the left. From the left side it is 3 centimeter. So whatsoever the point will come over here at 3 centimeters from the left, all are the possible positions. That means every point on this line is 3 centimeter from your left. That simply means we cannot precisely say that this is the point. It could even be the point, it could even be the point, it could even be the point. All points are your 3 centimeter from the left. And if I am going to say that the position of the point is 5 centimeters from the bottom, right? In that case, the position of the point could be anywhere lying on this line, because all the points on this line are 5 centimeter from the bottom. So simply by one reference only, we cannot locate any object or any point in any of the plane. For locating any point or any object in the plane, we want two reference lines. Now, if I am going to say that the position of the point is 3 centimeter from the left and 5 centimeters from the bottom, then the point which are going to incide, like over here, what we have done is whatsoever the points were there at 3 centimeter from the left, we have drawn a line. Whatsoever the points were 5 centimeter from the bottom, we have drawn a line. Now the point where these two lines are going to intersect each other will be the location of the point which we are talking about. That simply means whenever we have to represent any point or any object in the plane, we want two reference lines. So what we are doing is how we are representing any of the point in the plane. Let's discuss. So what we are doing is we are taking two number lines we are taking. This is one of the number line. Again, I am going to take another number line like this. Here it is 0. Here I am taking the positive numbers, and here I am taking the negative numbers. Now the two number lines I have taken perpendicular to each other. These two number lines I'll be taking perpendicular to each other such that their 0 is going to coincide each other. So what I have done is we have taken these two number lines we have taken, and the point where the O or the 0 is coinciding will be the common point. It is the point where both the lines are intersecting each other. Here we will be taking the positive numbers, and here we will be taking the negative numbers. Similarly, above we will be taking the positive numbers, and below we will be taking the negative numbers. So what we have done is we have taken two number lines such that perpendicular to each other, these two number lines are such that their 0 point is coinciding each other. Now this horizontal line is denoted by your x dash, and this vertical line is denoted by your y dash. This horizontal line x dash is known as x axis, and this vertical line y dash is known as your y axis. So this is your x axis, this is your y axis. When we are talking about only one axis, we are writing it as axis, that is your singular. But when we are talking about both the two axes, then the plurals becomes your axes. That means these two x and y axes are known as your coordinate axis. When we are talking about both the two axes, it is your coordinate axis. Now here if we are going to see towards your OX, this point where both the two lines are intersecting, both the two number lines are intersecting, it is known as your origin and it is denoted by O, capital O, and it is your origin. The OX, in this direction your positive numbers are coming, so it is the direction of your positive x-axis. If we are going to see over here OX dash, over here your negative numbers are coming, so the direction OX dash is your negative x direction. Similarly OY, this is the direction of your positive y, and this is OY dash, this is the direction of your negative y. So this is your positive x, this is your negative x, this is your positive y, and this is your negative y. If we are going to see the whole plane, then these two axes are dividing this whole plane into four parts. And because it is dividing into four parts, so 1/4 is known as your quadrant. That's the reason these four parts in which your axes are dividing the plane is known as your quadrants. These are known as quadrants. This quadrant, if we are going OX in the anti-clockwise direction from the OX, then it will be the first quadrant, it will be the second quadrant, it will be the third quadrant, and it will be the fourth quadrant. And this plane in by which is divided into your coordinate axis and your four quadrants, this plane is known as your Cartesian plane. This is known as either Cartesian plane, or we say it as coordinate plane, or we say it as xy plane. This is your plane which is divided into four parts by your coordinate axis. Now why it is called a Cartesian plane? Because the René Descartes, the great French mathematician, he is the only one who described the position of a point in a plane. How to locate a point in any of the plane is described by the French mathematician, and that's the reason the system used for describing position of a point in a plane with reference to two fixed mutually perpendicular lines is termed as your Cartesian system. The system which we are using to describe the position of any point in any plane using your two perpendicular lines is known as your Cartesian system. Now let's understand how to describe a point in a plane. If any of the point is given in a plane, how we can describe it? We can describe any of the point using its x coordinate and y coordinate. So how using x coordinate and y coordinate we can define or describe any of the point? Let's understand. Suppose I am talking about a point A. So what will be its x coordinate and what will be its y coordinate? So first of all, what we will be doing is from this point A, we will be drawing a perpendicular on the x-axis and we will be drawing a perpendicular on the y-axis. So from here, from the point I have drawn a perpendicular on the y-axis and on the x-axis. Suppose it is intersecting the y-axis at point M and intersecting the x-axis at point N. Now, the perpendicular distance of the point A from the y-axis taken along the x-axis is known as your x coordinate. The point A, the perpendicular distance of this point A from the y-axis taken along the x-axis is known as its x coordinate. So suppose this is your x coordinate, this is x1. So this x1 will be equivalent to your ON also because they will be parallel to each other. So this MA will be equivalent to your ON, or we can say it will be equivalent to your 3 units. Similarly, for this point A, the y coordinate will be the perpendicular distance of this point A from the x-axis taken along the y-axis. That means AN will be the y coordinate. And if we are going to see it, AN is equivalent to your OM. That means it will be your 2 units. So this is suppose your y coordinate y1. Then the coordinate of any of the point is written in the order. That means first of all we are writing is x coordinate, then comma, then y coordinate, and always in the small bracket. This is how we are representing any of the point. First of all we are writing the x coordinate of the point, then comma, then y coordinate of the point, and we are writing it in the bracket. This is how we are going to write its coordinate, and these are the coordinates for point your A. Now we can see over here, so x1 is your 3 units, This is your distance MA is equivalent to your ON, that is your 3 units. And your Y1, this is your Y1, that is AN is equivalent to your OM, it is your 2 units. So coordinate of this point A will be your 3, 2, where 3 denotes its x coordinate and 2 denotes its y coordinate. So what x coordinate was? X coordinate is the perpendicular distance of the point from the y axis taken along the x axis, and y coordinate will be the perpendicular distance of the point from the x axis taken along the y axis, it's its y coordinate. So this will be the coordinate for point A. Now let's see point B. Suppose this is the point B. Now first of all what we will be doing is we will be drawing the perpendiculars on the x-axis and y-axis. On the y-axis we have drawn it, and on the x-axis this is the perpendicular. Now what the x-coordinate will be? The x-coordinate will be your from here to here. This distance, the perpendicular distance of this point from the y-axis is its x coordinate. That means this distance is your x coordinate, or we can say this distance is the x coordinate. Now because it is the negative direction of your x axis, so its value is your -3. This distance is your, suppose this point I am taking it as x2 y2. The coordinates of this point B is your x2 y2. So this point, this distance will be your x2, and perpendicular to distance of this point from the x-axis, this distance is known as your y coordinate, and this distance will be equivalent to your this distance, that means from O to this, and this is your 4 units, that means this will be your y2. This is your y2, or you can say this is a y2. That means value of x2 is your -3 and value of y2 will be your 4. This is a positive y-axis, that's the reason it is +4. So coordinates for this point B will be -3, 4. X coordinate is -3 and y coordinate is your 4. If we are going to see the point C over here, so first of all what we will be doing is we will be drawing the perpendiculars on both the axes. We have drawn this perpendicular. If its coordinate is say x3, y3. So x3 will be perpendicular distance of the point from the y-axis. That means this distance. This distance is your x3, or we can say this is equivalent to this. On the x-axis, if we are going to see, this will be your x3. And perpendicular distance of this point from the x-axis will give you its y coordinate. That means this distance C from here to here, this distance is your y3, and this is equivalent to your this distance, so this is your y3. So if we are going to see, x3 is your -2 because it is along the negative x-axis, so it is your -3, and value of y3 will be your -3 because again it is towards the negative direction of your y-axis, so it will be your -3. So coordinates for point C will be -3, -3. Sorry, it is your -2, so it is your -2. Value of x3 is your -2, -3. Now if we are going to see the point D, first of all we will draw the perpendiculars. On the x-axis this is the perpendicular, on the y-axis this is the perpendicular we have drawn. Suppose its coordinate is your x4, y4. So what x4 will be? Perpendicular distance of the point from the y-axis will be your x coordinate. That means this distance. This distance is your x4 and this is equivalent to your this distance. That means this is your x4 up to here. This is your x4 and this is y4 is your perpendicular distance of the point from the x-axis. That means from here to here, this distance. This distance is your y4 and it is equivalent to your this. That means this is your y4. So value of x4 will be your 4, +4, and value of y4 will be -3. So coordinate of your D point will be 4, -3. The x coordinate of any point is known as your abscissa, is denoted by abscissa, and ordinate is the point of your y coordinate. Y coordinate of any point is known as your ordinate. x coordinate of any point is even known as abscissa, and y coordinate of any point is known as your ordinate. That means abscissa for this point is your 3 and ordinate for this point will be your 2. Similarly, abscissa for this point B will be your -3 and ordinate will be your 4. Similarly, for this point, abscissa will be -2 and ordinate will be -3. X coordinate for this point is 4. That means abscissa for this point will be 4 and ordinate will be your -3. So x coordinate of any point, x coordinate of any point is known as abscissa and y coordinate of any point is known as its ordinate. Now, if we are going to see over here, whatsoever the point will lie in the first quadrant, they will be of the form plus plus. That means it is enclosing between your positive x-axis and positive y-axis. This is a positive x-axis, this is a positive y-axis. So this is the area where your point will lie. So the form of the point will be a plus plus. That means the x coordinate will be any positive real number and y coordinate will even be any positive real number. Similarly, we can see over here the point which will lie in the second quadrant will have the form minus, comma, plus. That means its x coordinate will be negative and its y coordinate will be positive because this area is enclosed between negative x-axis and positive y-axis. This is the area which is enclosed between negative x-axis and positive y-axis. That's the reason the point will be of the form minus, comma, plus. First we are writing the x-axis, then we are writing the y-axis. That means its abscissa will be negative and its ordinate will be positive. So that simply means your abscissa will be your negative real number and your ordinate will be a positive real number. Now, if we are going to see in the third quadrant is lying between your negative x-axis and negative y-axis. That's the reason is abscissa and ordinate both will be negative. Both will be negative real numbers, right? Similarly, we are going to see the fourth quadrant. Any point which is going to lie in the fourth quadrant will be of the form plus, comma, minus. That means its x coordinate will be positive and its y coordinate will be negative because it is enclosed between the positive x-axis and the negative y-axis. That's the reason the point which will lie in the fourth quadrant will have the form plus, comma, minus. That means your abscissa will be your positive real number and your ordinate will be your negative real number. Now let's see if there is any point on the x-axis. Suppose I am talking about the point E. It is the point on the x-axis. So any point which will lie on the x-axis, its y coordinate will always be 0. That means the form of the point will be your x, 0. If there is any point lying on the x-axis, then always its y coordinate will be 0. Because what y coordinate is, just now we have seen that y coordinate for any point is its perpendicular distance from the x-axis. The perpendicular distance of the point from the x-axis is its y coordinate, and there is no perpendicular distance of the point from the x-axis because the point is lying on the x-axis. That's the reason its y coordinate will be 0. So any point which is going to lie on the x-axis, its coordinates will be x, 0. Now over here we can see x is your 5 and y will be 0 because it is lying on the x-axis. So coordinate of this point will be 5, 0. Similarly, if I am going to talk about this point, because again it is lying on the x-axis, so its coordinate will be -4, 0. Now similarly, if there is any point which is going to lie over your y-axis, then its x coordinate will be 0. Now see over here, suppose I am going to talk about this point G. So this point G is lying on the y-axis, so its coordinate will be 0, y. Its x coordinate will be 0. Because what x coordinate was, x coordinate is the perpendicular distance of the point from the y-axis, and the point is lying on the y-axis, so perpendicular distance of the point from the y-axis is your 0. That's the reason its x coordinate will be 0 and its form will be your 0, y. Now see, y is your 3, because this point is 3. So the coordinates for this point will be your 0, 3. Similarly, if I am going to see this point, so coordinate for this point will be your 0, -4, because this is even the point which is lying on the y-axis. That's the reason its coordinate will be 0, -4. Now, if we are going to see the coordinates of your origin, that is your center midpoint where your x-axis and y-axis is intersecting. So coordinate of origin will be your 0, 0, because the distance of this point from the x-axis is also 0 and from the y-axis is also 0. That's the reason its x-coordinate will be 0 and its y-coordinate will even be 0. So coordinate for the origins O will be your 0, 0 will be the coordinates. For any point which is lying on the x-axis, its y-coordinate will be 0. So it will be of the form x, 0. If there is any point on the y-axis, then its x-coordinate will be 0 and it will be of the form 0, y. So we can see the equation for the x-axis will be your y is equivalent to 0. This is the equation for your x-axis, because whatsoever the point will lie on this axis, for every point its y-coordinate will be 0. That's the reason equation for the x-axis is your y equivalent to 0. Similarly, equation for the y-axis is your x is equivalent to 0, because every point which will lie on this y-axis, for that point x coordinate will be 0. That's the reason the equation for the y-axis is your x is equivalent to 0. Hope it is clear to you how we can describe a point in any of the plane. For describing any point in a plane, we want its x coordinate and its y coordinate. For that, we have to draw the perpendicular distance on the x-axis and on the y-axis from the given point. The perpendicular distance of the point from the y-axis will be its x-coordinate, and the perpendicular distance of the point on the x-axis will be its y-coordinate. And once we are knowing the x-coordinate and y-coordinate, we can describe any of the point. First, we will be writing the x-coordinate, then comma, then y-coordinate in your small brackets. The x-coordinate is even known as abscissa and the y-coordinate is even known as your ordinate. The points which will lie in the first quadrant will be of the form plus plus, because they are enclosed between positive x-axis and positive y-axis. The points which will lie in the second quadrant will be of the form minus, plus. The points which will lie in the third quadrant will be of the form minus, minus, and the points which will lie in the fourth quadrant will be of the form plus, minus, where plus sign shows any positive real number and minus sign shows any negative real number. Hope it is clear how to describe a point in any of the plane. Now let's see how to plot a point in a plane if its coordinates are given to us. Suppose we have to plot a point A whose coordinates are 3, 4. We have just now seen that the first we are writing its x coordinate, that means it is the abscissa, and then we are writing its y coordinate, that is ordinate. That means x coordinate of point A is 3 and the y coordinate is 4. So what we will be doing is both of them, like x coordinate and the y coordinate, both are your positive. And just now we have seen if the form of the point is your plus plus, in that case it comes in your first quadrant. The point will lie in the first quadrant. Now see, the x coordinate is 3. That means on the x axis we will move to the 3 point. Over here this is your 3 in the x axis, this is a 3 point, and in the y axis it is your 4 point, that is positive 4. So in the positive y direction we will be seeing the 4. So over here this is your 4. So we have seen 3 and 4. On the x axis we have marked 3, on the y axis we have marked 4. Just now we came to know that the point is going to lie in the first quadrant. So from here we will be drawing a perpendicular in the first quadrant, and from here this point also we will be drawing a perpendicular in the first quadrant. So we will be drawing a perpendicular in the first quadrant. It will go somewhere here, and from here also we will be drawing a perpendicular in the first quadrant. The point where both of them are going to intersect each other, this point will be the point A, and its coordinate will be 3, 4. This is how we can plot the point. Now the second point is your 4, 3. This is the point B whose coordinate is 4, 3. Here even we can see that x and y, both the coordinates are positive. That means it is going to lie in the first quadrant. Its x coordinate is 4. That means on the x-axis we will mark 4. So on the x-axis this is your positive 4. On the y-axis it is your positive 3. Y coordinate is 3. So on the y-axis we will mark positive 3, because this point is going to lie in the first quadrant. So from both the 2 points in the first quadrant we will be drawing the perpendiculars, and the point where these two perpendiculars will intersect each other, will meet each other, that will be the coordinate of that will be the point whose coordinate will be your 4, 3. So from both the points we have taken the perpendiculars, and the point where they are intersecting each other, this is the point B, and its coordinate is 4, 3. Here we can see if we are interchanging the x coordinate and y coordinate, then their points are different, they are not same. That means this is your ordered pair x, y. This is ordered pair x, y, and if it is your ordered pair y, x. If it is your ordered pair y, x, then ordered pair x, y is not equivalent to your ordered pair of y, x if value of x and y both are not same. Over here x is your 3 and y is your 4. So value of x and y both are different. That's the reason if you are going to interchange x and y, they both will not be the same point. They will be different points. And if the value of x and y is same, in that case ordered pair x, y will be equivalent to your ordered pair of y, x if the value of x and y is same. If suppose this is your 3, 3, x and y both are same, in the case 3, 3, both your x and y both are same. So 3, 3 will lie, x coordinate is 3 and y coordinate is even 3. So this will be the point. This will be the point whose coordinate is 3, 3. And if I am going to interchange this 3 over here and this 3 over here, in that case also the point will be same, that is this is only the point. That means if the value of x and y both are same, in that case your ordered pair xy will be equivalent to your ordered pair yx if x is equivalent to y. But if x is not equivalent to y, in that case ordered pair xy will not be equivalent to your ordered pair y, x. Just now we have seen, we have interchanged x and y. Over here x was 3, so we have kept y 3. Over here y was 4, we have kept x 4. So if we have interchanged x and y, in that case they are having different locations, different points they are having, they are not lying on the same point. Now let's see the third point C, that is your minus 5, C. Over here this is of the form minus, plus. That means x is negative and y is positive. This type of form will lie in your second quadrant. Where this point will lie? It will lie in the second quadrant. So first of all we will mark minus 5. X is your negative 5. So negative 5 is lying here. This is the direction for your negative x-axis. So negative 5 will be, this is the point, negative 5. And positive 6. Positive 6 is your here. Positive y-axis, this is your positive 6. So because this point is going to lie in the second quadrant, from both the points we will be drawing perpendiculars in the second quadrant. So here from here I'll start drawing perpendicular in the second quadrant, and from here also I will start drawing perpendicular in the second quadrant. The point where they will intersect each other or meet each other will be the point C, whose coordinate will be minus 5, 6. Now see the point D, its coordinate is minus 4, minus 5. So just now we have seen if the form of the point is your minus, minus, then this type of point will lie in the third quadrant. That means the point will lie in the third quadrant somewhere here. Now the x coordinate is minus 4. So minus, this is your minus x direction. So minus 4 is here. X coordinate minus 4 is here. And y coordinate is minus 5. This is your direction for the negative y. And minus 5 it is. So this is your negative 5 for the y. Now because the point is going to lie in the third quadrant, so we will draw the perpendiculars from both these points in the third quadrant. From here I will be drawing a perpendicular in the third quadrant. From here also I'll be drawing perpendicular in the third quadrant. it will intersect over here. So this is your point D, whose coordinate will be your -4 comma -5. Now the point E, that is 7 comma -2. So this is of the form your plus comma minus. That means x is positive and y is negative, and this type of points lie in your fourth quadrant. So x is your +7. So x +7 here, and y is your -2. Y is -2. This is your negative y direction, -2. So point will lie in the fourth quadrant. So we will draw perpendiculars in the fourth quadrant from both the two points. From here I'll be drawing the perpendicular. From here also I'll be drawing perpendicular. The point where they will intersect each other will be the point E, and its coordinate is your 7 comma -2. This is how we will be plotting the points if coordinates are given to us. Now let's see the point 5 comma 0. This is the point F, that is your 5 comma 0. Over here we can see the y coordinate is 0, and if y coordinate is 0, the point will lie on the x-axis. We have already seen if the point is coordinates of the point is y coordinate is 0, in that case point will lie on the x-axis. So point will be 5, x coordinate is 5. So this is the point 5 comma 0, and it is denoted by your F. It is 5 comma 0. Next point is your G, that is 0 comma -7. Here we can see the x coordinate is 0 and x coordinate is 0 on the y axis. That means this point is going to lie on the y axis, and it is your 0 comma -7, that is y coordinate is your -7. So it is your -7, y is -7 here. So this will be the point G, and its coordinate is 0 comma -7. Now the next coordinate is 0 0, which is the point H. We know the point coordinates of the origin is 0 0. So this is the point, and its coordinate is your 0 0. So this is how, if points are given to us, if coordinates of the points are given to us, we can plot it in the plane. Now one more thing is, if we are going to draw the mirror images of a point, suppose a point is there xy, and if we are going to draw the mirror image of this point in x-axis, suppose any of the point is here, somewhere here. Now if we are going to draw the its mirror image in the x-axis, then this point will lie somewhere here. This point will come here, because this is a mirror. If we will be drawing the mirror image, this point will come here. So its coordinate will become your x comma -y. X will be positive in this quadrant also, but in this quadrant y will become your negative. So if we are going to draw the mirror image of any point of the form x comma y, in that case in x-axis if it is, so its y coordinate, sign of the y coordinate is going to change. X coordinate sign will remain same, but the coordinate of your y coordinate sign is going to be changed. If it is negative, then it will turn to positive, and if it is positive, it will turn to negative. And if x coordinate is negative, then it will remain negative only. And if we have to draw the mirror image of a point xy in y-axis, suppose this is the point, and in the y-axis I am to draw its mirror image. So this point will lie here. That means its x coordinate will, sign of the x coordinate will change. Over here your x coordinate was positive, but over here your x coordinate is negative. That simply means if in the y axis we are going to draw the mirror image of any of the point, then its x coordinate, sign of the x coordinate will change, but the sign of y coordinate is not going to change. If the sign of the y coordinate is negative, it will remain negative. If it is positive, it will remain positive. But the sign of x coordinate, if it is positive, it will change to negative, and if it is negative, it will change to positive. Similarly, if we have to draw the mirror image of a point xy in the origin, in that case sign of both x and y is going to change. So if point is here, if we are going to consider this as a mirror, then this point will lie here. So here x and y both were positive, and here x and y both are negative. So sign of both the coordinates of x and y are going to change. If both are positive, both will change to negative. If both are negative, both will change to positive. If x is negative and y is positive, so x will change from negative to positive and y is from positive to negative. That means sign of both of them are going to change, positive to negative or negative to positive. This is all about in this chapter. So you must have understood how we can describe a point in any of the plane, and if any of the point is given to us, if any of the coordinate is given to us, how we can plot the point in the plane. Thank you for listening to us, listening to me, and hope it is clear to you how we have done all this, how we have plotted it, what coordinate geometry is. Soon we'll be coming with the next video for other chapters of your syllabus also. Thank you.